So in this chapter, we're going to talk about the ocean water, or the properties, both physical and chemical, of the waters of the oceans, which then facilitate life. And so there's a lot of data that is collected by oceanographers, and they actually study the geography of the ocean, both the surface geography and the topography of the bottom of the water. And we talked about that in the last lecture series. They also study sediments and sedimentation of the ocean bottom, and we talked about that in the other lecture series as well. But there's a lot we have to talk about in this lecture series, which is the minerals which are in the oceans, the dissolved salts and dissolved gases in the water, which affect the water's salinity, or how salty it is, the temperature of the water, the acidity, the density, the life that lives in the water, in the aquatic ecosystems, the productivity of those aquatic ecosystems, or how much photosynthesis it's happening. And then for the next chapter, we're going to be talking about currents, waves, and tides, which is hydrology. But this chapter will focus from everything between minerals and the productivity of the water, and do an overview of the quality of the ocean water, or the properties of the ocean water. So let's talk about that. For starters, let's talk about dissolved gases in the water. Now, when you think of the atmosphere, you think of this layer of gas that surrounds the planet, and it's very easy to understand that there's oxygen in the air. But what a lot of people don't understand is that in the water, dissolved inside the water, in between the water particles, there's a lot of stuff. In fact, only 97% of the oceans is actually water. 3% of the stuff that you see when you stare into the oceans is actually stuff that's dissolved into the water. And so, the same way there's oxygen in the atmosphere, there is actually oxygen in between the water molecules dissolved in water. But not just oxygen. The main gases which we will find in the atmosphere are nitrogen, carbon dioxide, oxygen, and methane. And that's actually interesting, because if you think about it, these are the common gases in the atmosphere. The same things which are common in the atmosphere. Now, why would nitrogen, carbon dioxide, methane, and oxygen be so common in the oceans? Well, to be honest, for the exact same reasons that they're common in the atmosphere. Nitrogen is common in the oceans because it's common in the atmosphere. And a lot of the gases that are in the oceans come from the atmosphere. In fact, the major source of gases in the water is actually gases from the air. Gases can enter the ocean directly from the atmosphere and dissolve into the water. So, because there's so much nitrogen in the air, there's going to be a lot of nitrogen in the water as well. The same thing is true about oxygen and carbon dioxide and methane. But the oceans also get more gases in other ways. For example, methane gas can be produced by life, or a decomposition of life, or volcanic eruptions that happen underneath the water. Carbon dioxide gas can also be produced by life forms performing cellular respiration, as well as the volcanic eruptions that happens on the water, and also from organisms performing decomposition at the bottom of the oceans. And then the oxygen gas will come from the photosynthesis performed by algae in plants living in the oceans. And so these are similar sources to the sources that we talked about when we talked about those gases being part of the atmosphere earlier in the year. And another place that actually contributes to the amount of gases in the oceans are rivers, because any gases which are dissolved inside the rivers will enter the oceans once the rivers actually hit the oceans. And the same thing is true about lakes, when rivers hit lakes. And so the main sources for gases in the oceans are directly from the atmosphere, from life forms in processes such as photosynthesis, decomposition, and cellular respiration, also from volcanic eruptions and rivers. By the way, the same parts of the nitrogen cycle that happen in the atmosphere and land will also happen in the water. And so you have bacteria, and which are transforming nitrates and nitrites back to nitrogen, and that's another reason why nitrogen is actually added to the water. And so life forms are involved in the processes that transform the gases and make the water the way it is. But the gases can also come from volcanoes, from rivers, and directly from the air. Now, there are some factors that will determine whether or not more gas will be in the air, and therefore also in the water. Some of these factors, for example, are temperatures. Now, if you look here at the bottom left side, you see that there's a lot of exchange happening at the surface. And as the water moves because of currents and wind, it causes turbulence, or shifting of the water, which increases the amount of gas that dissolves into the water. Which means the surface of the water typically has more gases dissolved in it than the deep water, because the surface of the water is constantly mixed between the gas exchange and the turbulence of the air because of the waves. Also, it's the surface water that's constantly hit by things like rivers. And so the water is constantly being recycled. The oxygen is constantly being added to the water, just like a fish tank that has bubbling and pumps to make sure that the water constantly has a constant influx of air. The oceans constantly blasted with air from the atmosphere because of the turbulence, which is added because of currents and tides and waves, and then that will cause a greater exchange between the air and the water. Now, the deep ocean will have less gases because of that. However, if there's a lot of decomposition and volcanic eruptions happening at the bottom of the ocean and a lot of life forms which are performing the composition, you are going to get more nitrogen, more methane, more carbon dioxide in those areas as well. But you are not going to get too much oxygen in the bottom deep water because there's not a lot of production happening there. Because think about it, you're not going to have a lot of algae in the bottom of the ocean because it's too far away from the light. And so, although you may still have some carbon dioxide, methane, and nitrogen in the bottom of the ocean, oxygen is only going to be coming at the very top of the ocean where actually photosynthesis is happening or gas exchange with the atmosphere is taking place. So the depth of the water is definitely one factor that will affect the amount of dissolved gases, both because of access to the atmosphere and because of exposure to turbulence, which facilitates the exchange of gases, and also because of the proximity to the source of light, which is going to be adding the possibility for photosynthesis. Another factor is going to be the temperature of the water. Now, I don't know if you ever try to drink some warm soda, but when the soda is warm, you feel it, that it's not as gassy as it's supposed to be. It feels bland, or, it feels like it's been sitting out for too long, that kind of feeling. What's going on there is that hot soda or hot water can actually hold less gases. Because with the particles moving faster, the gases are allowed to escape the water easier. While if the particles are moving slower and they're actually colder, the gases are trapped as the water molecules are trapped in place and moving less. And so hotter waters can hold less gas. So if you think about it that way, the water in the tropics can have less oxygen and carbon dioxide in it, which means that the water in the cold areas will actually have greater amount of dissolved gases, which can actually facilitate photosynthesis. For photosynthesis to take place, you're going to need more carbon dioxide dissolved into the water, and then once the oxygen actually gets produced, the oxygen will get trapped into the water, which allows the animals to also live around the area to use that oxygen, which means the cold areas of the ocean typically do more photosynthesis than the warm areas of the ocean, even though there's actually more sunlight hitting tropics than the Arctics and the Antarctic Circle. Those areas are more productive because they have more carbon dioxide dissolved in the water, which is interesting. Now, the temperature is therefore a major factor of the amount of gases which can be dissolved in the water. And then during the winter, there will be more gases dissolved in the water than there will be during the summer, and there will also be more gases dissolved in the water in the Arctic areas than in the polar areas. Than the tropical areas. Now, another factor is actually water motion, like I said. Rivers which are constantly hitting the water with more gases, or turbulence caused by surface wind, like I mentioned, will also add the water. And then the last thing that can also add gases to the water is the proximity to the actual sources. In other words, if you're close to the air, close to life forms, close to volcanoes, or close to the rivers, the water will have more gases dissolved on it. So all these are very just the important factors which will affect the amount of gas dissolved in water. The depth, the temperature, how much the water is moving, and then the proximity to the sources, which are air, life, volcanoes, and rivers. Now, some gases dissolve in water, like nitrogen and carbon. Now, the actual amount of gas which are dissolved in the water can actually change the chemistry of the water. For example, nitrogen gas, which can react or be used by bacteria to be transformed into nitrates and nitrites, and also the carbon dioxide and even methane can all change the pH of the water, or the acidity of the water. Now imagine, for example, that you were living in an area that has an excessive amount of nitrates, nitrites, or carbon dioxide dissolved in the water. Those gases will actually often react with the water to create acids, which means the water's acidity level can actually increase in areas where carbon dioxide and nitrates and nitrites are very high. And so this can actually affect the ability of animals to perform their normal metabolic activities, and for example for coral to form, or for algae to do photosynthesis, and so forth. And so the acidity of the water is actually very important, and the gases as well as the solids which are dissolved in the water will affect that, and it will therefore also affect the ability of life to withstand that area. So, which is why too close to volcanoes, there's special life forms that can live in that place, because they have to be able to cope with not just with the temperature, but also with the acid conditions of the water near those volcanic vents, and which will definitely not be the same thing of a coral reef, which has to be maintained at a very specific acidity level. But ironically, the ocean water is typically a little it's more alkaline actually than actually acidic. And the water needs to be maintained in this slightly higher alkaline level in order for for the animals to be doing what they're doing. So when there's too much extra gases being dissolved in the water, that could affect the productivity of the water. And so when humans interact with the water environment and change the amount of gas dissolved in the water, either by pumping extra gas into the atmosphere, or by using fertilizer, and that basically runs off into the rivers and eventually into the ocean, all of that will affect the acidity level and the chemistry level of the water, and affect whether life can actually be sustainable there. Now, one last thing that I wanted to talk about is the idea of the oceans as something that actually controls the temperature of the world. Remember, you see here on the right side a mini carbon cycle, and you see that carbon is stored in three major places in the atmosphere. In the atmosphere, in the ground, actually part of the soil or of the rocks, or fossil fuels in the ground, and also in the water. And you can see that we remove those gases can go to the atmosphere by fossil fuel burning, by forest fires. When we use the land and cause erosion, that can also release carbon dioxide. Also releasing carbon dioxide is decay or decomposition, respiration by plants and animals, and things like that. And then also exchange with the ocean will either add or remove carbon dioxide from the water depending on the situation. But the only major thing that actually removes carbon dioxide from the atmosphere, it would be the oceans or the photosynthesis. And remember, the oceans also are performing photosynthesis, and so the whole carbon cycle is also happening. The same thing that happens in the atmosphere will also happen inside the water. So that means in the water, there's also going to be respiration, which was going to be releasing carbon dioxide. It's also going to be the decomposition, which is going to be releasing carbon dioxide. There will also be volcanic eruptions, erosion. There will also be decay, and all those things are also releasing carbon dioxide. But a lot of that carbon dioxide stays trapped in the water, although some of it can actually leave the water the same way it does come in. But a lot of carbon dioxide tends to stay in the water, and that's something that's interesting about water. It can store 60 times more carbon dioxide in it than the air does. So in any given place, if you find 1 unit of carbon dioxide in the air and there's a lake right underneath that, the lake most likely stores 60 times as much carbon dioxide, which means that the lakes actually work as something that we call the carbon sink, or a great storage place for carbon, all right, which allows to control the temperature of the earth, because carbon dioxide is a greenhouse gas. And so as much as the carbon traps is trapped in the oceans, it won't be in the atmosphere warming up the planet. The same thing is true about the methane gas, which is trapped in the oceans. The same thing is true about the water vapor, which is not evaporating. In other words, the fact that you have water in the oceans instead of the atmosphere, because water is a greenhouse gas as well, will also protect the atmosphere from increased temperatures. And the oceans also have to absorb a lot of heat before they actually evaporate, because remember, the water does not like to change temperature. So overall, the oceans act like something that controls the temperature of the world by not allowing it to go too high, by trapping carbon, methane, and water vapor, as well as trapping a lot of heat into the water. And so the oceans actually act like something that we call carbon sinks or greenhouse effect modulators because they protect us from increased levels of greenhouse gases, and also they absorb a lot of the energy that of the sun that hits the earth, instead of the earth warming up because of that energy hitting it. And there you have it. That's dissolved gases in the oceans. All right, next topic we'll do dissolved solids.